Hi, everybody. Thank you for checking out this video today. In this video, we're going to talk about rational versus irrational numbers. Once you learn the vocab, it's really not that hard of a section. A rational number, I see the word ratio in that. And when I think of ratio, I think of two numbers that are being compared. A lot of times you compare two numbers with fractions. So rational just means you can write that number as a fraction. All integers are rational. So negative numbers, 0, positive numbers. Integers do not have fractions and decimals, but integers are rationals. Now, with fractions and decimals, though, obviously a fraction can be written as a fraction since it already is. So those are rational. Mixed numbers, those go along with fractions. Those are rational. On your decimals, if they terminate means they stop. Terminating decimals, we've learned how to change to fractions, so those are rational. And we've also talked about how to change repeating decimals to fractions. Those are rational. So a lot more really will be rational than irrational in these problems. Irrational numbers cannot be written as fractions. They're decimals that never stop and they never repeat. The most famous, the most popular irrational number is pi. You see the symbol for pi right here. Pi, I guess that didn't circle like I wanted it to. Let's try that again. There we go. Pi, we use 3.14, but that's like an abbreviation of it. Pi really goes on forever. It never stops. It never repeats. It's irrational. And then we're going to start talking on this next slide about square roots. If you take the square root of a number that's not a perfect square, so you don't get a nice, neat whole number answer, that is also irrational. So squares and square roots. The square root is the number that you take times itself to get the square, which is the answer. So for square root, I just called it n. It just means some number. Squared is that number to the second power, that number times itself. So 1 to the second power is 1. 2 to the second power is 4. 3 to the second power is 9, and so on. This is the square root. It's what I'm multiplying times itself. This is the square. It's what I get when I take the number times itself. So if I ask you for the square of 9, the word square comes from area of a square, because in a square, all four sides are the same. So if you find the area, you take that side times itself, length times width, but they're both the same. A number times itself, square, second power. The square of 9, 9 times 9 is 81. The square of 12, 12 times 12 is 144. Square root of 36. So this is the inverse. This is the opposite. What I'm asking is, what do you take times itself to get 36? So your answer would be a 6. Now, there will be some times when it'll say find the two square roots, and you would need to put -6 and +6. That is not something that I'm getting into right now in this video, though. Square root of 9, what do you take times itself to get 9? The answer would be 3. Let's do some more. This sign is called the radical sign. The radical sign means what is that positive square root? Square root of 25, what do you take times itself to get 25? The answer is 5. Now, 196, if this isn't one that you know, I allow my students to use calculators. Eventually, the more you use these, the more you're going to memorize them. If you're not sure how to do the square root on your calculator, ask someone, ask your teacher, or reach out to me. You'll see my email and my classroom Facebook at the end of this video. Some calculators, you hit the number and then you hit the square root sign. Some of them, you have to do the shift key to get the square root and then you hit the number. It just kind of depends on your brand of calculator. The square root of 196 is 14 because 14 times itself equals 196. The square root of 441, what do you take times itself to get 441? That would be 21. Hold on, it's not writing. There we go. When they're fractions, that really means the square root of the top over the square root of the bottom. The square root of 4 is 2. The square root of 49 is 7. So this one really means the square root of 1 over the square root of 100. The square root of 1 is 1. The square root of 100 is 10. If you want to estimate square roots, so these are not perfect squares. If you do the square root of 27, you're not going to get a nice, neat whole number. These are irrational numbers. The decimals actually never stop. They never repeat. Here's what I know if I have to estimate and I don't have a calculator. I know that the square root of 25 is 5. The next one, 6 squared, would be 36. So square root of 27 falls somewhere in between. So that means my answer is going to be 5 point something. And I know that 27 is closer to 25. So I also know that it's going to be closer to 5 than 6. Now, if on an assignment you're actually asked to estimate, then depending on how close it is, you might want to say like 5.1, 5.2. But if you're just using this to put numbers in order, just knowing that it's between 5 and 6, but closer to 5 is probably going to be enough to help you. The square root of 96, well, I know the square root of 100 is 10. And before that would be 9. Let's see, the square of that is 81. So this is somewhere in between. So between 9 and 10, it's going to be 9 point something. And this one is closer to 100. So I know it's going to be closer to 10 than 9. The square root of 52, well, the square root of 49 is 7. The next one would be 8. That's 64. So this is somewhere in between. That means it's going to be 7 point something. 52 is closer to 49. So I'm going to make a note that it's closer to 7 than 8. Okay, let's put these in order. So I'm going to go through and simplify or estimate where I can. 0 is just 0. The square root of 4, well, that's a 2. The square root of 9 is 3. And this has a negative on the outside, so I'm just going to keep a negative on the outside. Square root of 10 is not a perfect square. But I know that's going to be this between the square root of 9, which is 3, and then the next one would be the square root of 16, which is 4. So this is going to be 3 point something, and it's going to be pretty close to 3. And then I've got 3, and then I have negative 2.5. Okay, so the most negative one that I have is negative 3. That was originally negative square root of 9, so I can mark that one out. The only other negative I have is negative 2.5. Let's see, so then 0 would separate the negatives and the positives. 2 comes before 3, so that was the square root of 4. And then 3 is going to be smaller than 3 point something. So 3 goes here, and then finally the square root of 10. You can do the same thing if they're negative numbers. Just remember, like if they're all negative, just remember negatives count backwards. Last thing, I want to practice just a tiny bit more with whether it's rational or irrational. Rational means you can write it as a fraction. Most things are rational. 5 is just a whole number. That's rational. 3.47, that's a decimal that stops, so it's rational. 0.6 repeating, it repeats, so it's okay, it's rational. Pi never stops and it never repeats. That is always irrational. The square root of 64 is really just 8, so that's rational. Negative 1, that's okay, that's rational. 0 is okay, that's rational. The square root of 120, if you check the square root of 120, it's not a perfect square. Square root of 121 is 11, so this is going to be 10 point maybe 10.9-ish, but it's not quite a perfect square. So this is irrational. You can do square roots of fractions, but to decide rational or irrational, you've got to see if those are perfect squares. 3 and 5 do not have whole number answers when you take the square root, so that is irrational. But just a normal 3/5, it's not saying the square root of 3/5, it's just saying 3/5. That's fine, that's rational. That's the whole section, folks. Hopefully that helps you with what you're working on. If you need any more help with 7th or 8th grade math, subscribe to my channel. It's Math with Luger. If you need any more help from me directly, there's my school email, or I do have a classroom Facebook. But hopefully that helped you some. I appreciate it if you toughed it out through the whole video. Until next time.